Hi, hola, bonjour, and Salaam. Welcome to Blueprint Bazaar. In part 17 of our plastic shredder machine full assembly walkthrough, we focus on a fundamental mechanical detail that ensures the longevity and smooth functioning of the system, installing bearings inside the mounting plates and validating their alignment using the powerful section view tool in SolidWorks. With the shaft, gear, and bearing covers now in place from the previous parts, it's the perfect moment to add the critical components responsible for reducing rotational friction, the bearings. We begin this part by bringing in standard bearing components into the SolidWorks assembly. These bearings were selected according to the inner diameter matching the shaft size and the outer diameter that fits snugly inside the pre-designed recess in the mounting plate. The initial placement is followed by a concentric mate between the bearing's central hole and the shaft's cylindrical surface. This mate ensures that the bearing's axis aligns perfectly with the shaft's rotational axis. Once the bearing is aligned concentrically, we move on to mate its outer cylindrical surface with the inner cylindrical recess in the mounting bracket. Here, a concentric mate, again, ensures that the bearing housing and mounting plate stay aligned. A coincident mate is then applied to the back face of the bearing to rest it flush against the shoulder or stopping feature within the mounting hole. This controls the axial depth and ensures the bearing doesn't float or misalign. To verify whether the bearing is placed correctly within the assembly and is interacting precisely with both the shaft and the mounting hole, we utilize the SolidWorks Section View tool. This tool allows us to virtually slice through the assembly and view the internal interfaces. With the section applied, we check the following. Is the inner ring of the bearing fully contacting the shaft? Does the outer ring of the bearing rest tightly inside the mounting hole without excessive gaps or overlaps? Is the bearing aligned straight and not skewed at an angle that could cause binding during rotation? These verifications are crucial. If the bearing is not fully seated, it could spin within its housing, leading to wear or even complete failure. Similarly, if the bearing binds against the shaft, or if it is misaligned, it can generate heat, noise, and vibrations, significantly reducing the shredder's mechanical performance and lifespan. After confirming the first bearing's position with the section view, we repeat the same process for the opposite mounting bracket. The same mated approach, concentric and coincident, is applied, and the section view tool helps ensure symmetrical installation. Proper alignment on both sides means the shaft is now supported uniformly at both ends, which is essential when the machine begins rotating under load. A quick manual motion test is performed once both bearings are in place. We rotate the shaft and observe its interaction with the bearing's internal ring. A smooth rotation without wobble confirms a proper fit. Additionally, we make sure that the shaft doesn't rub against the bearing covers or touch the mounting walls. Any contact could lead to additional friction or shaft wear. This part is particularly beneficial for viewers looking to understand the role of bearings in CAD assemblies and how real-world mechanical behavior is influenced by small components like fit, spacing, and alignment. We talk about tolerances, ideal spacing, and how real bearings require just enough play to rotate freely, but not enough to vibrate or dislocate. We also discuss the importance of axial restraint. Bearings themselves don't always prevent the shaft from moving left or right unless they're specifically designed with flanges or retainers. So placing them snugly inside accurately dimensioned recesses ensures that the shaft remains fixed in position even when torque is applied during shredding. Another key insight in this episode is how SolidWorks tools like Section View aren't just useful for presentations, They're essential for design accuracy. Complex assemblies, especially those with internal components, often require inspection beyond what's visible on the outer surfaces. Section view gives you the power to visually inspect and correct these hidden connections before moving to manufacturing. Moreover, this part introduces new users to the practice of precision modeling for motion systems. Beginners might often overlook bearing fits or rely solely on visual alignment, but through this walkthrough, they learn how to inspect, adjust, and validate these aspects using built-in SolidWorks functionality. In our final segment, we reiterate why this bearing installation step is a foundational milestone for the entire project. The shaft, now supported by both inner bearings, rotates reliably inside the structure. All moving parts up to this point, rotating blades, spacers, and gears, now have the required support to move without misalignment or drag. This not only prepares the shredder for future motion simulation, but also ensures that when we add the motor and transmit torque, the system will remain mechanically stable. If you're designing your own shredder or any rotating machinery, this part offers insights into bearing placement and alignment, fit tolerance importance, section view usage for internal verification, and shaft stability under load. This is where CAD modeling begins to reflect real engineering behavior, not just a virtual design, but a truly manufacturable, functional system. Understanding and achieving ideal shaft bearings. Interaction provides a practical learning opportunity. This part reminds engineers that while components may seem correct in isolation, their behavior under constraint and contact determines real-world performance. By taking the time to evaluate these relationships, you improve product quality and reduce risk during actual fabrication and testing. This process also teaches you to model with intent. Rather than just placing parts into an assembly, each component serves a role, and each mate carries implications for mechanical behavior. The shaft won't just spin, it must spin true. The bearings aren't just placeholders, they are the mechanical boundary between motion and frame. That intent needs to be respected in your modeling process. For teams collaborating across mechanical design and manufacturing, this part offers a communication bridge. Section views, bearing placements, and shaft alignment notes all help reduce ambiguity. Fabricators will know where bearings must press fit, where shoulders stop motion, and what tolerances they're expected to meet, all before a single chip is machined. It's also worth noting how SolidWorks empowers you to iterate without risk. You can test different bearing sizes, explore tolerance gaps, or evaluate movement, all before manufacturing. Learning to simulate and visualize these conditions helps new designers build confidence while offering professionals a toolkit for verification. Even experienced engineers benefit from pausing to revalidate something as basic as a bearing. In high-speed or torque-driven systems, even minor misalignment can cause major issues. That's why this part doesn't just feel like assembly, it feels like insurance. Insurance against error, wear, imbalance, or failure. By reinforcing the physical expectations within a digital space, you ensure that every part assembled virtually mirrors what's required in the real world. This focus on accuracy not only improves performance, but can significantly reduce maintenance issues and downtime once the machine is operational. This part also bridges the gap between CAD design and real manufacturing by emphasizing that mechanical reliability depends on precision at every stage, from virtual mates to physical tolerances. Proper bearing setup is more than just good modeling practice. It's a direct contributor to equipment life and operational safety. Finally, by mastering the section view inspection process, you gain a powerful habit that extends far beyond just bearings. Anytime your assembly involves internal alignment, pressure zones, or friction-sensitive contacts, this technique becomes your first line of defense against future issues. And that kind of foresight is what separates good designs from great ones. In the next episode, Part 18, we'll move forward with Toolbox section, where we add the screws, nuts, and bolts of the ISO standard, and prepping the fixtures. With shafts, gears, and bearings all in their correct places, now we have completed the overall design of the plastic shredder machine, and in our bonus videos, we will continue on how to make the bill of material, balance insertion, some shortcuts, and finally, the simulation and animation process for plastic shredder machine. Thanks for being with us till this part, and in the completion of this series, we hope to see you in our next fun series of another build. Stay sharp and keep building with precision.